start.
Sorry, we were just muted. Sorry.
So we can start now. I think that all the speakers seems to be online. So we now have half an hour intro to the discussion that will follow from 5 to 6 UK time. And first, we would like you to hear a short intro about the multi-messenger, multi-band astrophysics astronomy work package. And then we go to a short presentation from the pre-LIS AM subgroup, and they will tell us about their activities and the projects that they're setting up. And then we split into two breakout rooms, one on stellar binaries and multiples. If you want to join that one, you have to change the link and the room if you are here with us in person, and if you are interested in the pre-LIS AM observation of supermassive black hole binaries, then you stay at the same Zoom link, same room. So then our first speaker is John Baker, who is the chair of the multi-band astronomy work package, and he will give us some insights about it. So John, the floor is yours. You are muted currently.
Okay, do you hear me now?
Yeah. Yes.
Okay. Sorry about that. Yeah, so I just have a few minutes to give you a quick introduction to our work package team, and it doesn't really let us go into a lot of detail, so I mostly hope to give you kind of just a quick overview of what we're about, and maybe if you want to follow up some hooks to how you can learn more, and connect to us where it's appropriate. So the other leaders of the team are with myself are Zoltan Hyman and Samaya Nisanka, and just added yesterday we have two new leaders, Astrid Lamberts and Daryl Haggard. So you can reach out to us as a starting place. We have additional sort of expertise area leads, as we call them, people that we've identified to sort of span the expertise that we thought was relevant for the work package. And you can reach out to these people as well. They may say, I don't know, and not be able to immediately answer your questions, but it's a great link, and we can figure out where to go if there's a topic related to one of these areas that we should be doing more on, or something that that maybe is not on our radar that should be. Just now to give a picture of what we're about, this is just a sort of schematic diagram, roughly, not in any way really endorsed, of what the ground segment looks like. And you can, data comes in, it gets processed first at ESA, and then in the upper gray corner there is the consortium contributed data center processing. And so some of this was already discussed by Tyson, but I want to point out to some specific areas where the connection to the external community is important. And this is really what we see as our core role in the work package, is being that that bridge between the external community and the kind of formal planning at the consortium level within the project. And so a number of places where the external astronomy community is relevant in the user community, we need to have data for some of the science, key science projects and some of the science requirements. We need information coming in from the rest of the astronomy world. Some of the things the projects we already talked about really touch on some specifics there, right? And so we, a lot of questions that we already have. What external observations can start now? Obviously, the Astro working group's interested in this. What kind of coordinated and coincident observations should we prepare for, at the time of operations? How must the data be processed within the analysis for the science ground segment? And then, and what kind of external arrangements or maybe, formal agreements do we need to be pursuing? There's also, a list of key science projects that the consortium has identified as things that should be done once we have LISA data. And so we need to be asking questions like, what kind of external data do we need to fulfill those science objectives? And this is already developed. It's not, we're starting from nothing. And also in the science requirements document itself, the formal science requirements. And going around, right? So beyond the sort of consortium identified science projects, it's certainly expected that LISA's data will be useful for a wider variety of community-based science projects of some kind. And so in order to properly plan for LISA's data products, we need to have some models of what kind of community science projects there are, and to be ensuring that we're releasing the data and tools that are needed to support those kind of projects. So developing a picture of that. And then, more concretely, in terms of the data products themselves, we have spec source catalogs, alerts that come kind of real time, and then other kinds of products and tools that will come with the data. So what is the content needed in things like alerts? That's something we're working on right now. And in the catalogs, and what kind of tools do we need, and what do we need specifically to support various external specific user communities. Okay, so just currently looking at what our activities are, I have a little snapshot here. This is one of the places to learn about the work package. The LISA Science Group work packages document, which is snapshotted on the left. You can see its sort of serial number up in the upper left-hand corner of that snapshot, where you can look it up in Atrium if you want to learn more or look at this in detail. And we have a few areas, we sort of 4 areas of work for the work package that are in this box here. Science exploration, which we've already done quite a bit of, but we have some more formal work to do there. And this is an area where we, I think we're taking from, we will be, we're ingesting now at this stage more information on that from what's happening in the Astro working group. But we also have some more specific concrete things to develop there. Developing the joint analyses with LISA data and both electromagnetic or other type of data, as well as other gravitational wave data, and then the preparations that we need within LISA to make use of external data, including identifying the external data to use, and then various kinds of planning and logistics, right? So that's our formal plans, and that's this I sort of, and then the bullets below, I have planned work package elements there, but then also just to say, we have another kind of work, which is not the things that we have written in that document, but a number of kind of emergent tasks that come up when we're responsive to other parts of the consortium, and the needs that kind of come down from the project. And so right now we have a few things that are kind of in that area. This working on like a report on LISA alerts and a questionnaire on that. Discussions, and especially with the science interpretation work package on LISA data products, and other kinds of consulting with the LISA data processing group on the planning for the science ground segment. So those are the kind of activities that we have. And this is just a quick picture of what our whole list in that LISA Science Group document, or sort of formal plans, look like. There's a lot in there. We're not going to be able to cover everything. And on the right-hand side, these are a few specific projects that we are in various stages of really getting going now. It was already mentioned, the data challenges, and some of these are connected to the Astro working group already, but you can draw a map. So we have, things like this astronomical signatures of LISA sources, right? We would like to have kind of a catalog of electromagnetic counterpart reference models that can be used both within the project and helping to develop both a theoretical and observational planning sort of community-wide. We have these mock data challenges to develop analysis methods. We need to be gathering data on both galactic binaries and understanding what kind of data to gather on galactic binaries and massive black hole binaries, as well as other sorts of astrophysical binaries. And we have some people identified both specifically on massive black hole survey data to be gathering now, as well as we're aware of these the efforts on looking at pre-LISA observations within the Astro working group, and we want to coordinate on that as well. so that's just kind of a picture of what our work looks like, and that is all I had to present. I don't know if there's time to do questions.
I guess we can take a minute. Does anyone have questions? I actually want to ask you a cheeky question that we forgot maybe to mention the difference between working group and work package. And maybe there are actually the majority of people here are quite early career science. You can say what is the difference?
Yeah, so I mean, I hope you got it kind of a picture. We're really on a little bit more on the side of the kind of nuts and bolts and concrete plans and deliverables that fit with the broader consortium part of the project. And so we're, it's not really, these are not so much science research type of tasks, and some of these are kind of scientific development areas and understanding science research, and maybe there's some science research in here, but our job isn't so much to do those things, but to assure that the right kind of things are getting done, and to be formalizing these things within the project, so that and coordinating with lots of different areas within the consortium, where we're trying to have an understanding of to actually do the concrete planning right now, and then eventually the development of the ground system. So so we certainly rely largely on the Astro working group and community to give us the content and to inform everything that we're doing, and hopefully we have opportunities to to ask for things, or to identify needs that may not be being met, and that maybe the Astro working group will contribute to, and that's kind of happening already. But hopefully that answers the question.
So John, can I add to that?
Yeah.
Yeah. So I think this is really an important distinction for those of us in the consortium, but the kind of work that gets done in the work packages, and I think the multi-messenger work package here is a real example of this, is defining what the workflows are going to look like after we have LISA data, right? So all of this has to be done and planned for now, before the mission is on orbit. And the sorts of things that you see going on here are interfacing with the work we do in the working group, because they're asking questions. What will you need to do the kind of science you're talking about? And then this work in these work packages then defines what those operations and what those products and what those interfaces will be, so that we can do this science when LISA happens. So if you're interested in that side of the work, or if you have concerns about that side of the work, or thoughts about that side of the work, then John and any of the work packages are the folks to talk to.
Yeah. Let me make one other specific comment that maybe I wasn't clear enough on, but on the right-hand side of the slide you see now, these projects are things that that really invite people to participate in, right? So if any of these sound interesting, or you're curious about them, please reach out to us. This is a sort of screen grab from the LISA wiki page on our team, but or you can reach out to us for other things you think are relevant as well.
Marta, is it an important question, because we are sort of short now? Okay, then we thank John for the intro. And we give the stage now to Thomas, who will say a little bit about the discussions that was going on stellar binaries observation.
Thank you. Yeah. We'll keep it short and sweet, because we will have a more detailed, more depth discussion later on after the session. But this was basically started with an idea from, I think Tom Prince actually approached JAS first, and then Kais kind of took over as the lead, so I'm kind of stepping in here. And then we had a few calls, some discussions on pre-LISA, right? So we don't want to be kind of just hanging around and sleeping and waiting until LISA flies. We want to be ready. And there were few telecoms where we discussed different aspects, different things we want to really make sure we are doing over the next 10 years or so to be ready before this applies. And after several telecons, few discussions, we came up with 4 main projects, whereas one of them is kind of separated into individual projects. And I'm listing them here. These are the 4 main projects we're going to work on over the next years to be ready for these. And let me just really briefly summarize them right here. So the first one is actually going along the lines, how to make the best use of gravitational wave data. What kind of EM data do we need for that? Is it a P dot? Is it a better inclination? Is it a better distance? Because we have limited resources, we can't do everything. So the question is, what is it, what we want to do? And Sweta Shah already started this kind of 10 years ago, but there's now more tools like Bayesian analysis tools. Tyson Littenbeck wrote a really nice tool to do that, where we can combine AM priors and then estimate gravitational wave data. And then the project would be try different priors and which prior has the largest impact on the gravitational wave data. Is it inclination? Is it distance? Is it a below? As an example. We have already a leads for those two. That's me and Kais. Then the second project is really preparing for these. The first one is more on the theoretical aspect. Where should we look for it? Where are the sources expected to be? Right? Where is it globular clusters a good place to look? Or is the galactic plane a good place to look? Like we kind of ask the theorists, tell us where we should look at the one point. Right? So that's kind of project 2. Still looking for a lead for that, but it's mostly in that sense theoretical approaches, which maybe goes a bit along the lines of about the code comparisons for project 1 what Valeria actually talked about. And then project 2B is on the more observation side. What instrumentation do we need? Right? Instrumentation projects are not like something you do in a year. That's a long-term project. So we want to make sure we think about every kind of instrumentation we need. Is it a high-speed photometer on a big telescope? Is it a high-speed spectroscopy? Is it whatever we think about it, right? So this is the kind of stuff really on the instrumentation side to be ready when Lisa produces data, that we can use this resource for follow-up. And still needs to be identified what it is. There's been a few discussion and then really look at it. Kevin actually volunteered to lead that group. And then project 3 is really calibrating the expected LISA population with pre-LISA data. So that's kind of on the theoretical aspect again, like, right, so what do we expect to see, and then calibrating the LISA data using that tool, but also on the observational side, building populations, going away from these, oh, we find these really cool binaries, to what is the population we expect to see. So both on the observational side and on the theoretical side. Okay, so this is project 3, where we have also lead Jan on the observational part, and hopefully maybe Katie Bradwick on the theoretical side. So these are kind of the 4 big projects. They are open. Anybody who is interested, please join. We're very interested to have as many people as possible, and it will be kind of a self-organized group of projects. And I stop here, and then we'll have more discussions.
You can share the link.
Yes, I can actually put the link in the chat. Yeah, I will put the link in the chat.
And the next pre-exam activities overview will be given by Alessandra De Rosa.
Yes, hi, good afternoon, everybody. And I'll try to share my screen. Yes, okay. Okay, I hope you could you see the screen? Yes, you could. So good afternoon, everybody. And yes, I will really briefly talk about this pre-LISA EM observation on supermassive black hole binaries from, the observational point of view. This work has been done in a very close collaboration with Delphine Porquet, who is not able to join today. So first of all, due to the fact that maybe, we don't know each other, with a very short presentation on Delphine and myself. Delphine Porquet is from Laboratories de Marseille in France. She's an expert on X-ray, optical UV as well, observation of supermassive black hole, mainly on AGN. And I mean, she mostly involved in X-ray spectroscopy. That means the diagnostic coming from X-ray plasma of the nuclear in the nuclei in AGN and the environment of the supermassive black hole. She's also involved in multi-messenger study of supermassive black hole. So this is why the involvement in LISA, so gravitational wave, supermassive black hole, and neutrinos from laser AGN. I'm Alessandra De Rosa. I'm from National Institute of Astrophysics in Rome, and I'm actually an expert as well in energy astrophysics of AGN and multi-well observation in either both in isolated system and in dual AGN. This is why my involvement on this kind of project. My expertise is mainly in accretion injection properties in inner structure of the nuclei through X-ray observation, and I also very close, involved in the study of mission concept in the energy domain, in particular on the scientific requirement of this sort and this mission. So, well, when Delphine and myself were a bit, thinking how to develop this kind of project, also considering all the, multi-message and multi-band effort that has been just presented. And this afternoon, this morning, someone was saying that, well, I'm an observer, how could I contribute to this kind of science? Well, our analysis on this study was just thinking to prepare, optimize the astrophysical scientific return on LISA on multi-messenger topic, but not only a multi-messenger topic. The main, our main, goal on this project was to try to organize or to collaborate in this pre-LISA EM observation of massive black hole binaries, the link between theory and simulation and observation, what we said this afternoon between the different projects that Marta and Lucio presented. And we also thought that it is very important to try to understand the link between the LISA community and other wavelength community. We were thinking today, of course, the PTA, but even the electromagnetic community, SKA, JWST, AGINA, and how the science from the electromagnetic point of view we need to explore, we need to include, considering also the galaxy in surface, the neutrino. We start thinking to some very, very preliminary sub-projects that could be somehow relevant for massive black hole to be observed from an electromagnetic point of view. We started from the dual massive black hole, the so-called dual AGN. This is where our expertise is the most relevant, I would say. And the possibility is the possibility in this sense is to build a catalog of dual AGN population that could serve as a simulation, a sample to understand if these guys could somehow become interesting target in the LISA wave, in the LISA domain. From the observational point of view, the most important relevant quantities when investigated dual AGN are how these sources compare with cosmological simulation or isolated simulation, how we could identify the most important observables in order to be compared with simulation. So the AGN volumetric luminosity ratio between the two massive black hole, the galaxy stellar masses, the magnitude, so on and so forth. What we learned from a observational point of view is that in order to find these kinds of candidates, we really need a huge effort in several wavebands. This morning, Elisa was telling us something about the effort that should be made in order to investigate dual AGN and supermassive binary black holes in different wavebands. If you go down to subparsec, so unresolved massive binary black holes, so for the electromagnetic point of view, the game became even harder because we do not have a unique signature of these sources. We have different techniques that could help us to list candidates, but none of them is exhaustive or the final one. So we should cross-check different techniques and try to build good candidates to be followed from now up to the ELISA signal to understand which will be the best way to select good candidate. And then, I mean, it will be also important the interaction with other gravitational wave experiment and, of course, electromagnetic part. We compiled a document, you may find here the link, with some idea, some useful link that in this starting project could be of help. And just let me stress that this activity from our side is just started. We were, of course, also in contact with the people involved in the multi-band and multi-messenger work package, and then we would like somehow to be as a support work for the people involved on this group. These are a kind of final slide to say how we could try to keep the community working on massive binary black hole involved in this kind of project. So our idea, it would be nice, if possible, to organize some mini workshop, even half a day, in order to compare each other, to talk about something that could be some relevant from our idea of pre-EM with Lisa. But please, if you have an idea, comment, question apart from this afternoon, you could add your comments in this doc that is open, so feel free to contribute. And also, of course, to contact Delphine and myself for any kind of question or proposal. I'll stop here. Thank you.
So I guess we kindly ask you to copy the Google Doc link in the chat so that people can go immediately and check it. And now we split into the breakout rooms. So supermassive black hole people stay in this room, and Alessandra, Lucio, and Marta, I guess, will be with you. And people who are interested in stellar mass binaries, follow me in the next room. And on Zoom, change the link that is indicated in the program.
Just for, because I'm not connected through Zoom right now, so maybe if it is possible to put either on the website or the email anywhere, like the links to all those documents that have been shared.
Yeah, so far I've been posting all the slides that I have on Slack, and I will try to gather everything.
Thank you so much.
Okay, so the room is one. Okay.
Alessandra?
Okay, yes, so we are here. Sorry. I mean, it's a bit hard try to coordinate from here. However, I will do my best. Let me say a few words more for all of you that are here. And Delphine and I just started this kind of activity. We also were thinking how to, make support for the people involved in, for example, supermassive black hole surveys in the multi-band and multi-messenger work package. We had, a first meeting with the people coordinating the package. So the idea, of course, is not to duplicate the work, but to do something together and try to help. Let me also stress, as said this afternoon, both Delphine and myself, we are observer, and we are looking on the electromagnetic part in the sky. So we should somehow, we are dual AGN hunters. So somehow it will be useful to understand how this kind of research we are doing could be of some help for the observation Lisa will do. I think that the best way to proceed, if you agree, is to share the doc. I just put the link on the chat. The doc is no, sorry. Okay, is here. Okay. Yes, and okay, so our first idea was to, as a starting point, was to the possibility to, I mean, it should be the final steps. However, we start from here to organize a mini meeting among us for some particular project involving PM, massive black hole, and the work package for multi-messenger, and so that it will be easier to share particular project. However, just let me say a few words about the project we outline here. The one about dual massive black hole population, which is the one in which I'm more familiar with, because it's something I'm doing. Is most of these sources has been detected serendipitously, and what we know they should be there, and probably as I said, there is not a single way in which we could have a look to candidates and say, well, yes, these are dual AGN, but we should consider different aspects. If you want to have the best angular resolution, then we will use some radio data in order to disentangle the nuclei parsec separation. If you would like to work on large sample of possible candidates, of course, we would like to go with the optical survey, for example, and this could be the link with also the massive black hole survey work package. And the best possibility we have to select dual active supermassive black hole is, of course, X-rays. But even in this case, we could be biased through the highly absorbed sources. And what we know is that these sources are actually host usually in a highly absorbed system. In order to understand the evolution of from merging galaxies to the dual AGN stage, we really would like to follow the whole evolution, starting for example of interacting galaxy, and even estimates of how many of them host active nuclei. Then follow the most promising of them with some more a small field of view instrument. I was thinking to the X-ray in order to identify the best observational properties of these sources. So the main objective of this project should be to better understand, to identify the systems that host dual AGN, so active galactic nuclei that are spatially resolved. Once we arrive at this point, and this point is not easy at all, I would say, then we should have the link with theory or simulation group that will tell us how and how many of these sources nearby or at high energy, at high redshift, will evolve to be LISA sources. So could be this kind of work, preliminary to understand the LISA rate events when we will have this data. For all of this I said, this of course is clear that this kind of project will need the contribution of expertise in different waveband, in different topic, the observer together with the people involved in simulation, and when And of course, well, it is nothing to say. People most involved in the simulation of expected signal in the LISA domain. And I don't know if I mean I don't want to talk too much. If you have a question, comment, or
yeah, it's Lucio. Alessandra, do you hear me? I wanted to make a comment on the idea of constructing this sample. So I think we discussed in the past that two issues that come up are one, that for LISA you need to look at dual AGNs that are relatively low in luminosity, because we are targeting black holes that are typically below 10 to the 7 for the LISA application. And the other point is, which is related to what we heard this morning about the potential kiloparsec problem, right? The fact that there are a lot of processes that can hinder the binary formation at a scale of a kiloparsec to a few hundred parsecs. So would it be possible, I mean, given your knowledge of the observational challenges, would it be possible to design the project so that the focus is to construct a sample of dual AGNs that are at a separation below a kiloparsec, so it can be as small as possible, let's say not larger than a kiloparsec, and also in a luminosity range that should be the proper one for the LISA black hole candidates. We can imagine to say if you have a black hole at 10 to the 7 emitting from point 1 to Eddington, the luminosity that you should have. So maybe you have a criterion like that to cap the luminosity of the sample, something like that.
Yeah, I mean, for the separation, I would say that of course most of the large sample we are observing are the one, I would say, between 10 and 100 kiloparsec, because they are the one in which it's easier to have a large amount of candidates and are easier, I mean, to follow with narrow band instrument. I mean, usually the best way to proceed is to have this large sample of candidate interacting galaxies from the infrared or from the optical, and then starting from some estimates we could have, for example, for emission lines, we have an idea of if the black hole inside is active or not. And then to follow with I mean, for example, X-rays or other signature of activity. So this morning also has been proposed the astrometry technique with Gaia that somehow could help us to have closer systems and close candidates even at high redshift, and this could be, in the sense of separation, a good starting point for the LISA band. So maybe we could, I mean, it's not easy because it's a kind of research we are actually doing, and but it's possible, especially looking at, for example, the astrometry with Gaia. It's going to open a new kind of search for large sample of good candidate. About the mass, well, this is a bit, I mean, a bit harder in the sense that for this low mass source, we actually really even don't know how the single one emits. So yeah, we could try to select the best one in mass for LISA, and yeah, I see this aspect a little bit more harder with the separation.
Okay.
Yeah. However, we could try to fine tune to the correct, because of course the peak of the distribution in mass we are observing something like 10 to the 7, 10 to the 8. That is a bit, I mean, borderline.
Yeah. Yeah, but at up to 10 to the 8, I think it's okay. But certainly, if we can push the focus more towards 10 to the 6, 10 to the 7, that would be.
Yeah.
Will also be different from. I think no study has done that, right? In the dual AGNs to restrict to lower luminosity, right? I think it's new by itself in a way.
Hmm.
I think John has a hand up, and then Marta.
Yeah, thanks, Lucio. Yeah, I'm sorry, I was away for a few minutes at the beginning, and I'm not sure exactly if some of these comments were already covered, but and maybe this is just kind of a question of scope, but you know, I'm thinking of pre-LISA observations. It says of massive black hole binaries, but for the LISA science, it's not just necessarily massive black hole binary identified massive black hole binaries, but you know, I mean, think right now we don't have any way to confidently identify a very close binary that would be kind of a direct LISA, you know, counterpart type of system. But we have all kinds of, you know, whole range of sort of hints and you know, auxiliary information that may be valuable, and it ranges from things where you have like a fair degree of confidence to things where you say, well, you know, we really don't know, but maybe this is relevant. Things like, you know, visually interacting binaries, or people have suggested like ULERGs or whatever that might be related with, but more generally, all of even just a catalog of galaxies, right, is a really valuable tool for a lot of the LISA science related to massive black hole binaries, and especially as Lucia was just saying, because LISA is primarily sensitive to what is relatively low range in terms of observational AGNs, small mass, you know, relatively small masses, and because most of LISA's events are likely to be what is electromagnetically considered high redshift, there's a lot of challenges to even, you know, get some of those bases covered. So I guess it's a question is, you know, that sort of more general information in scope, and I think there's a lot of opportunities coming up for those kind of extragalactic surveys that will add to this, but are we talking about that here as well? Sorry for going on so long.
Let me say that about because you talk about the catalog of galaxies. I know that in the massive black hole survey work package, one of the proposal was to build a catalog of select a catalog of galaxies from existing data and select good candidates of galaxies from mock data. So probably it is, of course, it is a very important activity that I suspect is ongoing, or it's going to start soon.
Marta,
Yeah, it's about, I mean, it's on the same lines. I mean, I think that there is a reason why we don't have a sample of faint dual AGN. It's not that people didn't want to look for them. It's just that you have a very small horizon. They're faint. I mean, we have to think in terms of flux, not luminosity. And so combining the rarity with the requirement also to avoid being contaminated too much by the galaxy luminosity, I think that puts serious constraints on trying to find faint objects. I mean, if you think just of single AGN, faint single AGN, we're only now, opening the realm of low mass AGN, low mass black holes that power faint AGN. So personally, I would be happy with whatever.
Me too.
I know if you find me some, I'm happy. I understand the concern that perhaps they're not analogs of LISA, but I prefer to start learning from a reasonable sample of something that is perhaps more massive than a sample of zero size that is what LISA would like to have.
So I think next is Aaron.
Hi, thank you. I'm an early career astronomer, so I'm going to give a little background that I worked with Julie Comerford, who does a lot of work with identifying dual AGN. I'm currently at Vanderbilt now as a postdoc. But talking about building catalogs of dual AGN, as other people have said, is really hard just because they're really hard to find in general for lots of reasons. But for example, if we created a catalog from deep Hubble observations and then narrowed it down to mergers and then looked for AGN in those, or look for AGN and then found mergers in those, we identified something like 10 confirmed dual AGN from X-ray, out of hundreds of thousands starting, and then hundreds, thousands of AGN, and then hundreds of mergers. So they're just really hard to find, and they're almost exclusively supermassive black holes, just because of luminosity cutoffs and flux limits for all these. But here's other methods I think that we can use for this. First of all, you're right, as was said, the dye detections is really exciting. I think I heard work going on out of University of Illinois doing things related to that, which is exciting. But also the idea of using simulations to essentially inform methods to find these systems might be an important middle step before we get to large-scale surveys that might be able to go to depth, like Vera Rubin for a large sky survey, or things like the Nancy Grace Roman telescope or Athena, and other telescopes like that. So I think the difficulty is mainly that just the range that we work in is something that's not really being probed well by our surveys currently. And we either have to wait or come up with hybrid methods of using simulations to essentially inform simulations.
And then John, you have another comment?
I'm sorry, I just left my hand up.
Okay.
In the room, yeah. Something.
I don't have a whole lot to add to this, but I guess I'm wondering regarding the sub-parsec, smoking gun signatures of black hole binaries. Maybe this is already included in like a sub bullet point, but one could also look for post-merger signatures. So there's been lots of work on this maybe about 10 years ago or so for flares in AGN disks after the merger of black holes, or the recoil or the effective mass loss causes shocks in a disk, and this happens on like days to weeks time scales. I don't have anything specific to add. I just was wondering if that's included.
Yeah, that thing. Alessandra,
yes. Yes, I didn't. It was very noisy for me. So Isabella, I have well understood. She was asking, the possibility to find some post-merger signature of AGN, some of the techniques and simulation that has been done to now. It's something like this.
Yeah, post-merger.
Yeah. I'm wondering if some of the plans for electromagnetic transient searches will include looking for these types of flares.
Yeah, we didn't put here in the test, but of course, yes, I would say, because it will be a very important, very important part in order to understand what we are going to expect. However, if you are moving the closer, so for the sub-parsec and close to and then the post-merger, of course, we could somehow effort another class of problems, I would say. As we listened this morning, we still don't know how we should expect to observe in the final stellar merger, disks, mini disks. Pedro did a very nice, of course, review of everything. In this case, just to echo what Marta was saying, we should be happy to see something, in the sense that I saw Maria connected. I don't know if she's still there. There are some very good candidates following photometric variability of these sources close to the merger. And even in this case, we cannot be sure they are binaries, because there are other possible models that are explaining the variability. First of all, the AGN do vary. So if we observe a new cycle of variability, and this kind of variability could be reproduced with the noise, And then this kind, however, let me finish this part. We have good candidates to observe. The point is that in order to confirm the candidate, we should look at the sources with deeper, long observation that to space telescope, most of the time we should request time that very often is not given to us because it's too expensive, and of course there is always someone in the review process that say, well, but the AGN are variable, so you are just looking at the variability of a single AGN. However, this part, also from the modeling point of view, would be very important because it will tell us how this source are behaving in the final stage of merging. Again, we still will have a problem with the mass, but of course we could have some nice hint from, for example, the PTA nanograph experiment in order to shed light at least of something of these sources.
Yeah, I mean, to be clear, I was thinking of post-merger. So rather than following variability, due to accretion or lensing, it would be a short time scale transient that you would expect for a single AGN. But I agree, it would suffer from the same problem that the AGN is variable for other reasons. And so you have to make better predictions for what kind of flare and what bands should occur. But it's,
Yeah.
I think Maria has her hand up.
Yes. Sorry, Maria, you're on the floor.
Sure. Thank you. So one quick comment to what Andrea is proposing. First, nobody has tried to do that, but it's even harder than detecting the periodicity, say. One, we don't have good predictions from the theory side. Two, it's not like persistent periodicity that you can follow up for years and it will stay there. It's a signal that will go away. And then how can you tell it apart from normal AGN variability? So I think it's exciting following up gravitational wave sources because we will have a sense of where to look. So that minimizes the false detection rate. But just doing a blind survey for post-merger signatures, I think that's really hard at the moment.
Yeah, I would agree, especially if the merger rate is really low, then the chances are so small. But if there was already some kind of search for typical signatures in AGN, there could be like a sub search as a part of that to, say, oh, maybe this is a flare that's only like a little bit and less and it's not periodicity. But also, yeah, there needs to be better models for what that would look like. Exactly.
I think the problem is always, okay, we have a good description of what quasar variability is, but say, as you said, this is rare, and the description of quasar variability does not describe 100% of the cases. So if it fails 1 out of 1,000, maybe this is what we will end up detecting, what deviates from the very typical AGN variability.
So there's again Martha and John. I mean, Martha first, I think.
Yeah, I just wanted to go back to the first project. So just to clarify what is the plan. So here the idea is to take all available observation of dual AGN from any type of search, X-ray, optical spectroscopy, and so on and so forth, and build a master catalog from which we can extract information.
Well, this could be a starting point. The catalog will not get much long, but yeah, the idea is it could be a starting point. It was just a discussion we started, and then we really would love to have the comments and contribution from everyone. For everybody would like to, is interested to contribute. However, the idea could be this one, try to characterize these sources.
No, from my point of view, just based on my experience, this would be awesome. When I try to, when I work on dual AGN, one of my problems in general is how to, I know how to select a dual AGN based on my criteria, but then I try to match the criteria of a given observational group, and I find a result. and then I try a different one. Because if I use a distance criterion, and that's something different compared to a velocity criterion. And so, for me, honestly, that would be awesome. So you have my vote, although I cannot contribute much to the observations.
Yeah, I agree. I think it's also necessary, it's a necessary starting point.
Yeah.
John,
Well, it's important to us as observer, because we started this search, as I was saying before, in different groups, starting from different samples, and then making line to say, okay, this is what we found. It would be nice. Yeah.
Exactly. Sorry, may I add something? So, you described your experience, and then we had, I think, Aaron, who described his experience, and you both started from different points of view, different wavelengths, possibly. I'm sure there are other groups that are not represented today, and perhaps, one could think of reaching out to. In my experience, when trying to find a coherent way of understanding what a dual AGN has not been simple. And so even just putting people together as observers and say, okay, my technique gives this, my technique gives this, and they differ because of this. For people doing simulation, so basically what you have written for me is just great. I really can see your train of thoughts, and I see how that could be helpful.
Yeah. John, you had your hand up.
Yeah, I raised my hand again. So, and I think I'm kind of going back to the same point I made before, but maybe try to be clearer. So, and it relates to the comment that somebody, I can't really see people in the room well, but somebody was asking about flares following merger and trying to observe those, right? So, from my point of view as this work package person, one of the things we're really interested in is developing the kinds of observational data that we think we'll need in order to conduct the LISA science related to massive black hole binaries, right? And when I think about that, there's different types of data. There's some that talk about the population in a way that overlaps, and you learn, you have a sort of comparative views of the same or closely related populations, and that will be very valuable when LISA comes. And I see the trying to directly observe dual and binary massive black holes electromagnetically as sort of fitting in that category, and it can potentially inform the theoretical models and things like that. And when I think about what observations we're going to directly make use of in some of the science case analysis, I don't usually think that the direct observations of these kind of binaries electromagnetically are probably going to be the main thing in there, but rather having a base of things like long-term, both in time domain and otherwise, catalogs of galaxies and AGN that can be used to look for those kind of smoking guns in association with a detected gravitational wave event. And so I'm really interested in seeing that kind of stuff developed. And so if there's a place in this project for not trying to directly observe binaries themselves, but this other sort of auxiliary observations that will support that effort, I think that's something that we want for the work package. But if that's not what people are trying to do here, then I can understand that as well.
Elisa?
Yeah, so this is maybe a naive point that maybe was already covered in your mind. Sorry if I missed it, but talking about building a catalog of dual AGN. So wouldn't it be nearly as valuable, or anyways valuable, just to build a catalog of galaxy mergers, especially of galaxies at the low mass end that could harbor the black holes that are going to be in the LISA band? Could that help in any way to constrain the merger rate?
If I can comment, I think it's a very good point, because as far as I know, there is no catalog of mergers of galaxies and masses, say, large Magellanic Cloud and below, which will be very likely numerous hosts of black holes in the LISA band. I think there are people who are working on building this catalog, but I haven't seen anything published. I don't know if anyone else on Zoom has comments on this, but I think it's something that is missing at the moment. Aaron has a comment?
Yeah, I was just gonna, I have a little bit of knowledge, but I definitely don't have all. So when you're talking about these, you always run into this problem of we're looking at higher redshifts. So we're looking at lower mass galaxies with higher redshifts. So you're gonna have low flux period is the biggest problem. And a lot of our methods have been more, for finding these things have been limited just in that we don't always know the best ways to do it. So a lot of things moving forward have been looking at using machine learning methods to essentially find these things for us in large pools of data. So that's one way we might start doing it, because it'll help us find these things in noisy data or at low, low signal to noise levels, low surface brightness. So that might help us in general for just finding the right host galaxies. But then if you also want to find mergers, then you also have to think about like what stage of the merger are you looking at? Because once you're talking about the black holes merging, these are pretty far into the coalescence phase, as we call it, where they're just a completely different beast of finding them, because the galaxies are pretty well merged. They might be disturbed, or maybe if you took a long time to get down to that level, maybe they aren't disturbed anymore, and you're looking for other triggers, which is why you might need machine learning to do this. But in that, you still need to train your machine learning, and you still need deep observations that can see these things, period, at the sensitivity levels you need. There's a lot of problems we're running into.
Why did you say high redshift? I mean, I agree it would be interesting to have it at high redshift, but even in the low redshift universe, I think a catalog of interacting dwarf galaxies would be very valuable.
Oh, yeah, absolutely. Sorry, I didn't mean to exclude them. I was just trying to
include. And Marta,
sorry.
Oh, sorry, Alessandra. Yeah.
There's some catalog of interacting galaxies, mid-infrared selected. They are not dwarf galaxies. They are, merging galaxies, whatever. And one of the study was to try to find a rate of dual AGN in these merging galaxies. This is, for example, I was thinking to the sample of Gold's sample, and there is an infrared selected interacting galaxies. And of course, they are not only dwarf galaxies, but there's something to start.
Can I have a comment to this?
Yes.
I mean, not only are these not dwarf galaxies included, but they are also late type galaxies, because they have the spectral signatures from muse to be detected. So they're also one special type of galaxy, and they do not have quiets and elliptical galaxies. So they go a lot of assumption to go from these galaxy mergers to from these specific galaxy mergers to galaxy mergers of all types of galaxies.
So there's Marta and Luke who have comment. Marta, maybe first.
Yeah, so there are samples of interacting dwarf galaxies. They were not selected for these purposes, but there are a few. But to add more confusion to this discussion, merging black holes may not be found in merging galaxies because the dynamical timescales may be long enough that the merger has passed by, I don't know, 1 billion years or more. So personally, I would caution to be careful about searching for merging black holes obviously not in merging galaxies at the early stages, because it's clear the black holes cannot have merged yet, but even in the post-merger phase, it may be too early for the binary to actually, for the black holes to have merged.
Yeah, Luke?
Yeah, my first comment was going to be very similar to Marta's. So, I mean, you can explicitly say that you expect these kind of galaxy merger features like tidal tails. They typically last roughly a dynamical time or a couple of dynamical times. whereas the merger process is explicitly an order of magnitude or more many orders of magnitude longer. So you would, I think, kind of expect not to see these signatures in actual LISA sources. But as a broader comment, I think it would be really helpful to kind of try to think about the specific science goals of developing these different resources. So for example, I mean, I think having catalogs of galaxy mergers would be extremely useful for kind of calibrating astrophysical models, but maybe less useful for actually hoping to have an idea of priors for where to look for electromagnetic sources. And I think more broadly, that's going to be very true because our ability to be complete at these low mass galaxies is going to be really, really limited to the very local universe, whereas the sources that we're likely to detect are going to be at redshift 1, redshift 2 or so. So our ability to kind of have a catalog of galaxies that are likely to then host sources, I think is very unlikely. Whereas having these catalogs for kind of doing astrophysical modeling and calibration and studies on the physics, I think that's still going to be absolutely invaluable.
Then we have another comment. I think Aaron also.
Yeah, sorry, I keep on speaking up. Not meeting.
I know.
But related to this, I think related to as Caleb had been saying, there has been work at the supermassive level for like supermassive black hole mergers, used essentially to estimate, the supermassive black hole merger rate, and this is related to nanograv and PTAs. So out of Colorado, Joe Simon, who works with nanograv, I know has been working on essentially trying to estimate the supermassive end of this. And if we're looking to estimate it for ours, I mean, it's a similar process, but it's going to be obviously different in application with the things we look at. But it might be interesting to try to see how that's being approached and if there's any methods that can essentially carry over in that way.
So I was thinking about another aspect that might be interesting. Maybe it's difficult to carry on, but you highlighted the subparsec and the dual AGN cases, but we have one only example, as far as I know, of a double black hole at few parsecs of separation. This is the Rodriguez et al. Source that is identified in the radio with the two radio sources. How, and this is a question to the observers, how interesting might be to see if with the SKA precursors like MERCAT, for example, we could build a search. This is maybe a long-term project, but we could build a search for this type of sources at few parsecs or even few tens of parsecs separation in the radio. It's just a general question, how feasible or not feasible that would be. I mean, I'm not a radio expert, so I'm just asking, if there is any radio expert in the group online or here.
Yes, it's just some comment on the chat. Sarah Books Polardon have done and working on that and radio survey, yeah. But I mean,
They are working on it.
Yeah, so Sarah Burks-Pilar and a few other radio observers, they've done these types of studies, mostly looking for higher mass dual AGN sources. And I know that numerous other surveys are ongoing. So I think this is something that people are working on, but it would be very interesting to understand how likely they are to detect sources and kind of the mass range that we're interested in. It's something that I don't have any sense of offhand.
Yeah, thanks. And
I know this search, they did a deep search that was not, high, relative in terms of detected sources. However, it is true that a radio survey could afford the best angular resolution, so could let some out. But even considering that 10% of AGN are radio loud, so even the detection actually would be not that high. However, we could not.
Yeah.
Really.
So John and Maria have also their hand up. John first, maybe.
Okay. Yeah, I like the way Luke described the question of what identifying the importance of identifying what the sort of scientific objective is of the type of observation. You know, what we're supposed to apply these for scientifically, right? And I think, you know, a lot of this discussion mainly goes toward understanding the populations and the models that are relevant for LISA. I mean, so, and if we're thinking about LISA, right? I think this comparison with what we have in the pulsar time is very valuable. So there's a lot of observations that people are thinking about that will help inform the population for pulsar timing. So compared to that, what different observations, how would you add on to those observations to make to get information that's more specifically related to the LISA population, which, you know, is related to but distinct from the one you have for pulsar timing. So and you know, this is also kind of a question maybe for the theoretical modelers, right? What are the areas where some observations would be particularly valuable in informing what our predictions for LISA populations are?
Maria?
Yeah, I had a comment mostly on your question, Lucio, on doing these radio surveys. And I'm not an expert, but my understanding is to do these VLBI observations of the parsec separated binaries, you need very deep observations of specific objects. So the thing is how you go from a big survey with a large field of view, find some tentative evidence, and then identify objects to go deeper and search.
Yeah.
So I think that's a complicated, because the better resolution you have, the smaller the field of view, right? So there's a trade-off there. Very challenging. I think Luke is right. Sarah Burke-Spalor's thesis back in the day was starting from these surveys, finding interesting objects, and then following up. And I think from that, they placed a limit on what is the level we expect these systems to happen.
This is Maria. You said that the best example for what is happening now with Gaia, because there are different techniques we are using in order to select dual stuff, something closer that could be everything stars in the projected view or whatever. And there are three different techniques, as far as I know, they used in order to select the duality. And few sources among the plethora of Gaia sources satisfy these criteria, and then they are followed up with the high resolution, other information. The most important is the optical one as an observer, because you look at the lines and you see what you're looking for. And so the point is exactly what Maria was saying. If you have a large salvage, it's not easy to select the good way you wanna look for deeper. However, I think that with Gaia, for example, in the next year, we will build several other candidates. The point is the mass, that will be quite high. And however, for the redshift, for example, with Gaia, I'm sure they could go up to higher redshift with respect to we are observing now with the X-ray or other weapon.
Elisa?
Just a point that is maybe more related to the second, subparsec binaries and this idea of how to find them. Because I have in my mind the fact that the big ellipticals are stored in the center, and this is due to the action of binaries. At least that's the common belief, right? And those are, of course, going to be too massive for LISA, and anyways probably already merged as far as we know. But if we think about smaller systems that possibly host nuclear stellar clusters or anything like that, that show a lower stellar surface density towards the center, also those systems could potentially have a relatively short relaxation time compared to Hubble time, meaning that by the time the binary merges, after, I don't know, a giga year or 5 giga years, that the surface brightness in the center will rise again. But in the time that the binary is there, perhaps we can actually see this like missing light in a way. So I was just wondering if it is in any way possible observationally to search for these, depleted central regions in galaxies that are not like the big ellipticals, to really like point towards them and look for binary candidates.
Well, I would say I don't know. I really don't know. I think it would be, I would do something about it, but I cannot comment. However, it would be interesting to check. If it's visible, it would be a nice way to see it, but yeah.
Marta, you have a comment on this?
Yeah, I was wondering whether the problem is that, the cores in a small galaxy will have a very small physical size. Already for the big ellipticals, they are basically barely resolved. So I would imagine that unless, before 20 or 30 meter telescopes, it would just be hard to have enough resolution to find a change in slope to parse, except in the, for instance, if you go to the Milky Way dwarfs, they can do these studies, Fornax and things, but usually they look at dark matter properties, and I would imagine that for those, I don't imagine that there are lots of binary black holes. But I think, in my mind, this is the main problem, just angular resolution.
Yeah, probably, yes, that's main. Yeah.
I have a question that maybe has an answer. I'm just not familiar with the topic of dual AGN so much. So you need both black holes to be accreting enough to see them. Do we know what fraction of if you have a galaxy merger and a second black hole, and what fraction of events both black holes would be accreting? Is that something we know from larger scale simulations, for example?
You mean which fraction of the?
Which fraction of mergers should produce dual AGN as opposed to just having a second quiescent supermassive black hole?
Well, I think this was a question for Pedro, maybe. He did, a lot of a plethora of simulation, and for Marta as well, of course. I think that the most fair answer is it depends of the mass of the source you're observing, the mass of the galaxies, the luminosity you took as a threshold. But I'm sure Marta could comment much more than me on this. I could say that at least, for the different sample we analyzed and the few dual we found, the fraction of dual we found was something like between 10 and 20%. And there is some kind of simulation able to explain this fraction. This is the answer I could say as an observer. And for the simulation point of view, I think it will really depend on the threshold you put on different aspects, on the ingredients you put inside, I think.
Yeah, no, I know you did you said everything, Alessandra, but yeah. So for instance, one difference is also what type of probe you look for. Spatial separation versus spectroscopic separation, you have different thresholds there. And so you have different answers. You don't have a unique fraction of dual AGN. And then also when you go to cosmological simulations, and Alessandra was the lead on a review on this topic, we also looked, and depending on how you define your what is a dual AGN, and how you consider the properties of the simulation, or it's the same for observations. If you put a threshold in galaxy mass, in black hole mass, in luminosity, you just get different results. So that's why I was saying that, you know, a type of exercise that makes a uniform sample, although selected different, and then we can test our models on this. And then we can go back to simulation and ask which of these duals are more likely to give rise to binaries and eventually mergers. To me, that was why I thought that Alessandra and Delphine's idea was excellent.
Thanks.
Yeah. Yeah, I think I agree. I mean, this is at least the only way to start. Of course, then it's unclear how to map it to the small scale. That's a general problem. But at least we need to know more information on the dual AGN state. And that's something we need anyway.
Yeah, so let me stress that, as we said also at the beginning, of course, it is an effort that should be, I mean, would involve people expert in different web band and different, I mean, aspect of the topic. So, I mean, this would be very well welcome to contribute.
Yeah. John?
Yeah, I had yet another different idea, I guess. But another approach to this whole area, which can, I think, support certainly the trying to identify dual AGN, but maybe other things to be valuable for Lisa as well, is not to start with the kind of observations that you would ideally like to be looking for and understanding them specifically, but to start from the observational side and to kind of look specifically at the kind of surveys like Roman and blanking, LSST, whatever, and to kind of to think through those, and and other things, right? There's a number of other, obviously those are kind of in particular bands, but there's a whole bunch of work that you can kind of see now is likely to happen before Lisa comes, and to start with that and say, what in this data is likely to be useful for Lisa and for some of these objectives, and then have that as a starting place for thinking of both what kind of analysis or preparation of that data might be valuable, but then also what other additional data might be particularly important to collect in contrast.
Yeah. No, I think you're completely right. And actually, going back to something that was shown in the white paper review this morning, there are, I mean, as we've seen from Elisa, from Pedro, and Melanie, there are many processes that scales of kiloparsecs, which are, in the range that is more accessible to observations in galaxy mergers or galaxy interactions, that are relevant for allowing or not allowing the formation of the binary, which is necessary in order for the binary to merge later. And these processes are known from the modeling and theoretical point of view, but we don't know much or not enough about their occurrence in mergers, I think. For example, the bars that Elisa has shown are really important to determine the stochasticity of the binary evolution or the clumpiness of galactic nuclei. So these are things that are not related directly to the black holes, but they are necessary in the modeling. We need to know more about these in the modeling part to understand how they affect the black hole evolution. So I think these kind of things, I guess this is probably along the lines that you have in mind, John. These are things that are useful for Lisa, even if they're not directly related to the black holes themselves. So quantifying these structures in mergers, for example, that would be interesting. I don't think it's been done well enough for, I have never, there's a lot of stuff in galaxies, but not specifically of mergers that also involve clumpy galaxies, for example. That's an obvious thing that maybe just with the data around already can be done. Maria?
I think another thing we will get from having these large surveys is automatically getting these galaxy catalogs that we will need for the LISA follow-ups. Now, a good question is like, what other quantities we may need on top of the whatever LSST or Roman will give us. And potentially this is the mass of the galaxy that will give us the mass of the central supermassive black hole. For us to determine whether it's a good host or not, we probably need the distances. LSST will not give those. So I think that's another thing we need to think how we can work with these surveys to add more useful quantities, let's say, for these observations.
Yeah. Aaron, and then John again.
Sorry, just to follow on to that beautiful segue from Maria. I just wanted to say that, you know, at Vanderbilt, we're starting to think about doing projects like that, specifically, essentially creating large galaxy catalogs purpose-built for multi-messenger, you know, observation or multi-messenger missions with LISA from these large surveys. So like with current ones, you know, things like Sloan and WISE in order to estimate redshifts and galaxy masses, because those are the main things you're going to need, because as I said, they inform us of distance and mass. And then also looking forward to how then we can apply these same methods to essentially future large volume surveys, such as, you know, Vero Rubin, which I think will have also LSST, same thing, have like the largest volume, I think, in the foreseeable future for looking for these kind of objects. So it's actually something that we've already started thinking about and will be developing over, you know, multiple years.
John?
Yeah, I think all of it is, I agree with everything you three, you know, just said. I think that sounds great. I think, you know, like concretely, in terms of project, I would suggest an element that focuses on, you know, a sort of assigning, you know, a task to go and study particular catalogs that are expected to come out, and then consider the information in there and start classifying it. How is this useful? Is this useful for LISA? How is it useful for LISA? And then you can follow on, as Maria was saying, in, you know, what do you need in addition to that to realize that utility?
Yeah. Okay, I guess we are already past the hour. So unless people have more comments, or maybe Alessandra, you want to close?
Yeah, yes. So I have to say that, I mean, of course, I mean, preliminary work has been done with Delphine, and we will be both very happy to your comment on the document or just contacting us by mail. And just a very, very final comment regarding the last sentences of John. It's our question about this kind of stuff, how the other waveband mission can help LISA, or how this other multiple mission can help our understanding of massive black holes. I mean, of course, we should do something that would help the LISA science, but also the synergy with other facilities, in the sense that what these other facilities will learn more about massive black hole together with LISA will allow us to learn. This is actually the steps we did within the white paper. So asking ourselves how LISA with other electromagnetic mission could help us to increase our understanding of massive black holes. Probably there are two different aspects of, quite close topic.
And I think John is thinking more about the second one, you know, at least the helping LISA in a more general sense. But I mean, I guess they're both valuable, right? And your project with the dual AGNs is more connected to the black hole physics path, right? But I think it's useful as well for LISA. So
yeah. Okay, thank you for the discussion, and yeah, thanks Lucio for leading
Thank you so much for organizing this.
Thank you, everyone.
Thanks. I think the other room will return at some point.
Yes.
So for people on Zoom, we'll stay in this room and then they'll join us.
They're gonna join.
Okay.
Yeah. So while we are waiting, so the next step will be you call a meeting with the group of the specific group of the massive black hole.
Probably it would be useful in view of everything we said now. I mean, with people involved in the web band, making comparison with people doing simulation. Yeah. So we try to organize something, maybe now, of course, after summer, and let's hope before the end of the year.
Yeah. Okay. So they're more resilient than us.
But they have real source to look at.
Exactly. So while we are waiting, but in any case, the idea is clear that this dual AGN catalog is something that will have the priority, right, in life.
Yeah, I mean, yes, but maybe it's a bias from our side. However, we think that something useful could came from research as well from this catalog. Let's hope to be able to, I mean, to discuss with other people about this, but probably it would be very useful.
Yeah. I guess we can take a break.
Yeah.
Yeah, I think so.
Yeah.
Well, I'll check what's
Exactly.
happening. And
Yeah.
thanks, everyone.
Guardando, diciamo, queste osservazioni si scopre che le call, diciamo, da sempre con la bulk relation non è esattamente giusto, la call possono essere più piccoli del previsto. Cioè, in
Tu dici
generale,
le galassie in cui ci sono questi processi o diciamo?
ma diciamo se il black hole andando a high temperature sarebbe da capire bene se le reazioni scaldano
Sì,
perché se non succede, cioè se il black hole è più massiccio di proporzione alla galassia non verrà sicuro.
Sì.
Questa è la ricostruzione. E quindi il tuo modo di portarli giù è completamente basato
Basato sui torsi, quelli che sono, ci sono già un po' di risultati su questa cosa che dice, però per le cose molto complesse. In quel caso sembra che tendano a essere overmass, mi pare che la maggioranza dei risultati danno overmass, però non tutti, c'è anche qualcuno, se non sbaglio, che va a quelli.
ma se sono
Però sono tutti very bright agents, perché sono tutti, non c'è nessuno esorbitante, questi sono tutti RC2 o più, quindi sono identificati come phasers o AGNs, e se non sbaglio sono tutti sopra, cioè se si dice che sono edito limited, sono tutti sopra il 10 volte. Quindi in realtà sono fuori dal suo. È da controllare. Mi ricordo avendo guardato un po' di papers negli ultimi 2 anni che sono tutti. Sì, esatto. Non c'è senso di che non credo ci sia una misura di queste deviazioni.
So we now have 20 minutes or so to summarize the day. How many? I'm not on Zoom. How many people?
21.
We can still like do the summary, and I guess it would be interesting, like what we both everybody attended the talks, etc. It would be interesting to compare what the two groups just talked about, and we were interactive. For us, time just fast fly, and we ended sort of on a discussion of what instruments do we want, and it was just never ending. Thomas, do you want to, because you took the note, maybe you can like take a couple of points that we discussed, and then we can compare what has been discussed here. Maybe there are some instruments that we want together.
On the spot. Well, we talked a lot about, we started actually our discussion with combining simulations with EM observations. So, right, so predicting what EM observations we want to do, want to focus on as an inclination, is it the period, orbital decay, stuff like that. And there were different ideas of low signal noise ratio sources, what do they actually give in gravitational waves on top of EM observations. Then we talked about the accreting systems because they will be guiding the X-rays. What can LISA give us there? And then when we talked about like what is it for data validation for LISA, because that has to be done. Like when are we confident that it's actually working? So one of the things was, which I didn't know honestly, was that systems which you already know of, but on a frequency band where there's actually lots of sources, it will take time. Even though it's there, it will take time to actually get the frequency resolution to actually see extract the distances. So ideally, you would have a source where there's no other source. So really in that frequency range. And that's something we talked about how we could do that. Then we talked a lot about theory side in the sense of binary populations. What do we? Where are the limits? What do the EM observations can help us there? Is it space densities was a big topic, which is quite hard, but still it's very important. Selection effects, then maybe looking at the progenitor systems, right? The wider binaries, so the kind of the steps before, that was a big topic, which I think we don't really think too much about. I really appreciate that comment. The ways to find them. We talked also about planetary systems. There's predictions. Camilla actually mentioned that there's predictions of circumbinary planetary systems, which should lead to a timing measurement. With timing measurement, you'll be able to find that. And we talked about these things and how to do that. And then the last thing was about instrumentation, right? In the era of ELTs, in the era of kind of ELTs becoming more the standard because everybody's jumping on ELTs. Want to make sure we have this instrumentation. So, for example, for us, a big topic was like high-speed photometry, high-speed spectroscopy, because these systems have very short periods, and you need to be able to resolve them. Don't smear over that. So one of the things was making sure we're getting our instruments there, because currently that's actually not the case. Currently, these instruments are not built for high-speed anything, really. And then infrared is a big topic in the galactic plane. Infrared, you need infrared because it's good. So one of the things was also some of the instruments existing already, maybe try to put them permanently on now the 10-meter class telescopes, which will still be highly oversubscribed, but maybe not as bad anymore, and not even jumping on the big ELT. So that's something which is more of a long-term project, but try to make sure that we don't miss any of these opportunities where there's calls to push for that kind of thing. So I think that's kind of some of the notes I have. I don't know. Is that an over there? You want to add something?
I think that's okay. And we also said that this community should be used as a tool, I don't know, to back up proposals, right? Yeah. If there is a need for an instrument that will benefit LISA, and yeah, I mean, we are here to.
And especially if it's an instrument which is interesting to the supermassive black hole community, right? That's something we should then, as a whole, jump on as much as we can, because big communities typically help.
Thank you. And to we have a volunteer for the supermassive black hole binaries?
Alessandra, you still alive?
Yes, I'm here. Yeah. Well, yes, I'll try to be brief as well. And we start discussing some possible projects on massive black holes as a proxy for LISA sources. And we were discussing two main projects. The first one was the related to the possibility of investigating or making a catalog of what we know now on dual AGN detection, that from electromagnetic counterpart is a kind of study very heterogeneous with different selection criteria and many variables entering the game. So a uniform list is not available to now. And we also have discussed in the case of still a massive black hole at closer separation, so the sub-parsec AGN, to the possibility to check, resolve, and quantify the genuinity of the texture signature of these sources, that is, even in this case, not homogeneous and mainly biased through other characteristic of single AGN. It has been also proposed and outlined that apart from the dual AGN or binary system, it will be quite useful to have a study and possibly a list of interacting galaxies or interacting dwarf galaxies that would be the best target in which look for LISA target list. And we also discussed about the idea of the possibility to have a sample of galaxies as observed for future facilities like LSST, and in order to understand which kind of information we'll be able to get from this huge survey in order to, get some hint on LISA PM sources. And well, at the end, has been also, outline how are we able to extract the right information we need from the large sample of galaxies, for example, with Roman we will have in the future, in order to get the good information for LISA. Well, I have to say that maybe the final we share a document in which we outline a few of these projects, and with the idea to involve more people on this. The best way to proceed is to get people involved, contacting me on Delphine Porquet or other people involved in this work, and make a comment on this document. That is, however, I think is already on Slack. And it will be nice to try to have a mini meeting, something like half a day, to discuss more clearly and more in depth what we think about this couple of projects on dual and binary massive black holes. And well, this was more or less the notes I took. I don't know if I forgot something, or should I read?
Thank you.
We can just add maybe this idea that I think John put forward and we discussed a bit towards the end. That there might be also some useful things that we could do that are not directly related to finding or detecting massive black hole binaries, but that might be useful to understand things related to them, and therefore they are relevant to LISA. For example, properties of most galaxies and other things that are necessarily related to the AGNs. So this we left it as another, point to keep in mind, that apparently the multi-messenger group thinks is also useful and beneficial for LISA in the long run.
Okay. I also wanted to give the opportunity to maybe Shane and Marta add something if they want to, because they are not here with us.
No, I'm certainly fine. I think it was great. We had lots of great discussion today. So I appreciate everyone participating, and I appreciate all the effort into making the hybrid work. That was really helpful, and I think it worked pretty well. So.
Yeah, it's very well.
We also appreciate from our side your effort to shift to the European time. I hope that press now. Okay.
And I don't really have much to add. So hopefully, during this meeting, we will continue making progress towards projects for both theorists and observers.
Okay, then let's end it here, and we see everybody again tomorrow morning at 9:30 British time, and we will have full morning of exciting results from our junior LISA scientists. So that will be the highlight of the day. See you tomorrow.
Bye, everyone. Thank you.